What we actually want to look for is drop away, the angle by which the horizon deviates from a great circle as we rise in altitude. Recall that a great circle cuts the sphere exactly in half, so a horizon at eye level means equal parts sky and earth on the celestial sphere, while drop away means more sky than earth. A single photograph takes only a small part of the celestial sphere, where this proportion depends entirely on how the camera was tilted. To make matters worse, a photograph doesn't capture gravity, so by looking you can't know how it was tilted except by assuming the horizon to be eye level, which invites circular reasoning in favor of a flat Earth. I'm convinced the intuition of flat earthers makes this error on a routine basis. We can avoid the whole thing by taking a full panorama. Late last year, my friend Victor Brewer of Aerial Image Solutions took panoramic footage of the horizon at an altitude of more than 120,000 feet. Victor's work has gotten attention before. One of his previous balloon launches was attended by Rob Skiba, a well-known flat earther with 170,000 YouTube subscribers. Victor's most recent launch was featured in the Creation Guy's Faith on the Edge documentary. I played a modest role this time, helping analyze his footage. Links to both it and my analysis are in the video description. With a full panorama, the orientation of the camera doesn't matter. To show drop away and a spherical Earth, all we need is more sky than Earth.
The panorama is half sky and half land. And if it's half sky, half land down near the ground, you have a base starting point. And then you go up in altitude. Now, if you have the same amount of sky as you have of Earth, there's a real problem there. But if you have less Earth and more sky, you know that there's drop away occurring. And if there's drop away occurring, that can't occur on a flat plane.
According to flat Earth theory, the closest point from our camera to the supposed Antarctic ice wall, if it gave way to immediate void, would produce horizon drop away of less than 13% of 1 degree. Even this generous figure would not be measurable by our method, so if we measure any, it shows a sphere. Victor provided me with 6 cubic faces of the panorama, matching at the edges and oriented upright. All 4 sides showed more sky than Earth. In fact, they showed perfect balance, with the horizon quite clearly falling below the midpoint by the same amount on all 4. This amount was 6 whole degrees. Does this agree with the globe model? To answer that, we needed to measure the altitude. The bottom face of the cube showed geographical features of known size, which allowed us to triangulate an altitude of 120,120 feet. This was roughly corroborated with barometric data collected during the launch, and puts the globe model prediction for drop away within 3.9% of our measurement. This tiny error is well within the precision of the experiment. If we wanted to increase the precision, we would begin accounting for well-recognized but normally negligible factors: ground level above sea, oblateness of the Earth, etc. My belief is that most of our imprecision comes from atmospheric refraction, but the fact that we measured any drop away at all shows the Earth to be a sphere, and the amount we measured shows a radius of 4,000 miles.